In this lesson, we are going to work with the vertex form of a quadratic function. We will learn how to identify the vertex, graph equations in vertex form. There are two methods for that graphing, so pick the best one that works for you. And then we will also identify the domain and range of these graphs. So let's first look at the vertex form. Just like linear functions have multiple forms, linear functions can be in standard form, slope-intercept form, or even point-slope form. A quadratic equation has multiple forms. You should have previously learned the standard form, ax squared plus bx plus c. So the vertex form is f of x equals a times x minus h, all of that is squared, plus k, where the vertex is the hk ordered pair. The a in the vertex form works a lot like the a of the standard form, that you can determine if the graph opens up or opens down, and also help determine maximum or minimum value for the vertex. So let's review that first. If your a is positive, that means your graph is opening up towards the positive. If you imagine drawing an xy ordered pair or xy ordered xy axes, then this graph would be pointing in the positive directions on our y-axis. So if a is positive, it points towards the positive, and that means our vertex would be a minimum. So if our a is negative, again, that means it will open towards the negatives. Here's my vertex. It's the highest point on the graph, so that means the vertex will be a maximum. So let's look at some equations in vertex form and be able to identify the vertex and also determine the max or min. So for our first example, we're going to have y equals 2 times x minus 6, all of that is squared, minus 7. We're going to find the vertex, and we're going to determine if it's a max or min. So be careful with vertex form. We notice that it's in this form. We have our a, we have our x minus h, and all of that is squared, and we have our k. When you're naming your h value, because it says it needs to be minus h, if you already have a minus sign, then you just take the number that you see after the subtraction sign. We're used to calling that a -6 when we name our numbers or our values. But because it says it has to be minus h, we only take the number after that minus sign in order to identify our vertex. So for our vertex, our hk is 6, comma, with the k, you do take the exact symbol that you see. So -7 for our ordered pair. Always be careful though with that h. It's very easy to misnaming that by its sign, because if you see a negative, you want to write down a positive. For the k value, you write exactly what you see. So because our a value here is positive, in order to determine if this vertex would be a max or min, since our a value is positive, we would have a minimum, because that positive value would mean our graph would open up, and here's our vertex, so that would be a minimum value at -7. You use the y value of your vertex. Let's look at another example, number 2. Here we're going to have y minus 4 equals 7 times x minus 2, and all that's squared. Well, notice this one is not in vertex form. So this says that everything has to be on one side of the equal sign with f of x or y. This is the same thing as just saying y equals. So that's not happening here, but we can solve for y and get y by itself. So add 4 to both sides. Be careful you're not going to add it with this 7. You would have to have an x minus 2 quantity squared with the 4 in order to add it to the 7. We can kind of think about they're not like terms. So the plus 4 is just going to be tacked on to the end and be our k value. So we have y equals 7 times x minus 2 squared plus 4 in vertex form. So our vertex is going to be named by our h, k. So here's my h. Again, it says negative. You want to write down the opposite of what you see because that negative is supposed to be there. By vertex form, it says it's supposed to be minus h. So that's what we have. You write down the opposite of what you see. So 2 comma. For the k value, write down exactly what you see. I see a positive 4, so I'm going to have a positive 4 for that vertex y value. Go back and look at your a value to determine max or min. So my a value is 7. So a equals 7. That is a positive number. So because that's a positive number, that means my graph is going to open up, and that would make my vertex a minimum. The value of that vertex, the minimum value, the lowest this graph goes on a graph would be at 4, that y value of the vertex. Let's try number 3. Y equals negative x plus 8 quantity squared plus 1. Feel free to pause the video and try this one on your own. Let's see how you did. It's already in vertex form. So when we name the vertex, we should name our h, k, but notice this time it says plus 8. In order to be in vertex form, it has to say minus. We have a plus sign. So that means we're going to take the opposite of what we see. Negative 8 would be our h, because if you think of subtracting a negative, that makes that positive. So a negative 8 would be the h value. The k value, you take exactly what you see, the positive 1. So our vertex is negative 8, 1. To determine if it's a max or min, go back and look at your a value. This is actually a negative 1 for our a. So a is a negative 1. Because that is a negative a value, that means our graph is going to open down, making that vertex the highest point on the graph. So it's going to be a maximum value, and we use that y value of our vertex. So a maximum value of a 1. Let's do one more before we start some graphing problems. Number 4, we have 14 plus y equals negative 1/2 times x plus 3 quantity squared. We're having a plus 8 there at the end. Woo! It's close to vertex form. We have this 14 over here on this side with the y. So it's not quite in vertex form just yet. We have to get that y by itself. So subtract 14. We have y equals this first part, the a and the x plus 3 squared, that a part, and the x minus h squared part, all of that part of the vertex form was fine. The plus 8 is not really your k because we had to subtract the 14 from 8. That will make it become a new k value because the 8 was never really our k value to begin with. So 8 minus 14, we find that we get negative 6. So that vertex, use your h, k value. So h, we want to take opposite of what we see. So we have negative 3, comma, for k, take exactly what you see. So vertex negative 3, negative 6. When we think about our max or min, go back and look at your a value. If a was negative 1/2, We don't really care so much about the value, so the 1/2 or the 1 or the 7. So we don't care so much about the value of A as we do the positive or negative. So A is negative, meaning our graph's going to open down, making that vertex the highest point on the graph. So it means it would be a maximum. The value of that vertex, the maximum value that that graph is going to reach, is -6. Let's practice some graphing problems now. So we're going to go back and actually use this first example to graph. So for our first example, we have 2 times the x minus 6 quantity squared minus 7. We identified our vertex. The first method of graphing, so I should call it method A, is a lot like when you graph standard form. You find that vertex, you put it in the center of the table, you complete the table and graph the points. So let's go ahead and do that. We have already identified the vertex to be at 6, -7. In your graphing calculator, you will take and press Y equals, it's the top row of buttons, hit Y equals. If you have anything in there, go ahead and clear it out. It's also good to notice your plot 1, 2, or 3. Make sure those are turned off. If ever turned on, arrow up, press enter, and that means it's turned on if it's highlighted, or arrow up and press enter and it turns it off. Doing a calculator reset, so let's write down the steps for a reset. Is always the easiest fix when working with the calculator, and if it doesn't do what you want it to do, if you press the button second, that's the blue second key, and then memory, it's the plus sign, and then just the numeric keys 7, 1, 2. So that will always be helpful if your calculator's not doing something you think it should be. Just do a calculator reset, and that usually clears out whatever odd setting is going on to keep it from working. So, when we have our graphing calculator, we have hit the Y equals button. We're ready to type in our equation into that Y1. So go with the original equation where it's set equal to Y. So 2 parentheses, X is the button underneath mode. You can do alpha X, but it always takes me a while to search and find that X. The button right there under the mode will work for the variable X. Minus 6, close the parentheses and square it. You use the X squared there in the first column or even the caret key under the clear. So square. Make sure, yep, it's not in the exponent anymore. Sometimes your cursor will stay up there in the exponent, so make sure it's out, and it is. So then minus 7. When we go second table, we know our vertex is at 6, -7. So we'll scroll up or down depending on where your table's at already in the calculator. Scroll and find those numbers. You want 2 less than and 2 greater than. That way it makes a nice U shape when graphing. So we find 4, 1, 5, -5, 7, -5, and 8, 1. Hopefully you've already started noticing the repetition from graphing standard form. You should see that again in vertex form. So our vertex is in the center of the table, and then it should cause some repetition from either side. And you could continue to scroll through and see it goes beyond just these 5 points. It will continue those repetitions to make that U shape continuing. So let's go ahead and plot these points. So for our graph, I tend to start at the vertex. So 6, -7. And then go either way. You want to go left of the vertex or right of the vertex. I'm going to go with the 5, -5, so it's to the left. So there's 5, and then and then 4, -1. No, 4, +1. 4, +1. And the reason why I tend to like to start at the vertex first is because it should make a mirror image, so that way if you're miscounting, you know where you've gone wrong. So going here now, that was 6, so here's 7, -5, and then 8, +1. So it keeps them having to recount so many times. If you just start maybe at the vertex and then know that it's making that mirror image. Sometimes students will find that their graph is making a W rather than a U, and that may be because their vertex is just in the wrong spot. So always be mindful of if you've plotted in the correct direction. Like for example, I almost plotted that at a -1 instead of a +1. So just always be careful that that U shape should be formed when graphing these quadratics. So connect the points. If you'd like to label the axis of symmetry and vertex, you're welcome to do that again in this lesson. However, it is not a requirement because we've already practiced that. But notice the axis of symmetry will be the same as your H value, which we identified earlier at 6. So if we drew a dashed line here through the graph, it would be at 6. And then we said it had a minimum value of -7. The graph goes here all the way down to as low as -7. So we can use that minimum value to help name the range. As you previously should have learned, domain is all real numbers. If I talked about the x values on this graph, eventually this graph will continue forever in both directions, reaching every single all real numbers for this graph. The range, because it opens up, our a value is positive, we'll say that our y is greater than or equal to, and we said it was here at this -7. It opens up from -7, that minimum value, and every y value greater than that number is part of our graph. So let's look at a second method for graphing these. So going back to our original function, we have our vertex. We still will identify that first. So for method B, we're actually not going to call it x and y in our table, and this is still number 1. We're not going to call this x and y in our table. We're going to call it x from the vertex and y from the vertex. So you're not going to talk about so much as an x and y ordered pair like you would from the origin. We're going to talk about x and y from the vertex. So still starting with 6, -7 as our vertex, we will go ahead and plot that first. Rather than getting the whole table, you're actually going to start by plotting that point first. So going to 6 and down to -7. Because everything is going to be graphed from that point. We're not going to count from the origin any longer. We're going to count from the vertex. So for this method, we start, like I said, with our vertex. Go ahead and graphing that on the graph. And then you use your a value to help you determine how to move from that vertex point. So what you do is you take and write an equation, y equals your a, the 2, x, and square it. Okay, oh, I went down here. Right here, we're going to take our a value, 2, with an x and square it. So when we talk about moving away from the vertex, we're going to say we're going to move one x value away. So we want to go one place away from the vertex. So if we take 2 times 1 squared, 1 squared is 1, and 2 times that would be 2. So from our vertex, we're going to move one x value away and 2 y values away. So that means going up +2. You can also go in the negative direction, 1 x value away and 2 y values. So we're starting to see that U shape, and we already know it's correct because we graphed it using a table, but that's how you can move from the vertex and not always have to count from the origin. So let's get some more points. This time we're going to say we want to move 2 x values away. So we said we do this as ax squared. That's where we get the 2 from. From up here, this a came from the fact that it was this 2 in our original equation as our a value. So 2 times 2x squared, because we're going to move 2 x values away from our vertex. We're still moving from our vertex, not the origin. So 2 squared is 4, and 4 times 2 is 8. So this time, again, starting back at our vertex, we're going to go 2 values away from the vertex, and then we're going to count 8 values from that vertex on our y. So go both directions, positive and negative from the vertex. So 1, 2, 3, 4, 5, 6, 7, 8. And we've already checked it, or we've already graphed it with another method so we can see that it is checking out. We could even go 3 values away. 5 points are plenty, but I know this is a new method, so I'm going to go ahead and show you how to do, 3 x values away. But this would be plenty to be a complete graph. So 2 times 3 squared. Always be careful with order of operations. I find that some students want to multiply first and then square it, and that's breaking the law of order of operations. Make sure you do exponents first. So 3 squared is 9, and 9 times 2 will give us 18. So we're going to go 3 x values away from the vertex. 3 squared was 9, and 9 times 2 is 18. I don't even know that we have 18 to count, but you could imagine if we were 1, 2, 3 away, we would count 18. We barely, that's 17, so it would be what? Here. And of course you could check that with the graphing calculator if you still have your table of values in there. So that's how this method would work, and that's a common way of graphing quadratics. You take that a value from your equation, once you've already graphed your vertex, you use that a value to help determine how you will move from the vertex. So ax squared, and then evaluate that for 1 and 2 places away from the vertex. Of course, don't forget to connect your points and make that smooth curved line, making that U shape. All right, let's look at one more example for graphing. We're going to use a new equation now. So we'll have example number 5. We have y minus 8 equals -3 times x plus 1. All of that is squared. We would need to identify our vertex regardless of what method we're going to use for graphing. But notice this is not in vertex form, so make sure you solve for y and get it in vertex form first. So we get y equals -3 times x plus 1 squared plus 8. We're going to name our vertex. It's our HK point. So H, take the opposite of what you see. So I see a positive one, I'm going to write down a negative one. And K, write down exactly what you see. If you want to identify max or min, because this has got an A value that's negative, it should open down, but we'll see that as we start graphing. With it opening down, it'll have a maximum value at 8. So let's use the table of values method. This vertex will go in the center of our table, so -1, 8. Go to your graphing calculator and type in the equation, being sure that you use the one that's in the y equals form. So here we're going to type in -3 parentheses x plus 1, close the parentheses and square it, and of course have that plus 8 at the end. Always double check and make sure you've typed it in correctly. Sometimes that is the most simplest error that causes you to miss the graph because you've made a calculator error when typing it in. Go second table and scroll up and down. We need to get to -1. So sometimes students will notice that they've made an error in typing in the equation by this table of values. Beside the -1, you know it should be an 8. Also, this will help you know if you identified the vertex correctly. If you accidentally, for some reason, look at this as a +1 for your vertex and then knew to use the 8, well, look beside the +1. We don't have that as our ordered pair. So you could really use the calculator to help you check your answers in a lot of ways. So here with the vertex, we have the -1, 8. We want two numbers less than and two numbers greater than that. So we've got -3, -2, 0, and 1, and fill in those y values that correspond to them. -4, 5, 8, 5, and -4. I'm going to wait on graphing, that way I can show the other method. Obviously you could plot these points and get the graph on the graph paper. But let's go ahead and look at the second method. So this table of value is for method A. Let's look at method B also. So for method B, you're going to go ahead and start by plotting this point. You don't have to go straight to a table first. So -1, 8. So that is the first thing we need to graph, is that vertex, because everything's going to be moving from that point and not always from the origin. If you use method A, that table of values does graph from the origin. So for our method B here, we need to go back and get our A value. Get our A value from our original equation. So we're going to write an equation, y equals ax squared, replacing that with our A from our equation. So we have -3x squared, and this will help us to determine how to move from that vertex to get our other points. So we first want to move 2 points away. We want to move 2 points away from our vertex. Well, 2 squared is 4, and 4 times -3 is -12. So we're going to go to our, I don't know why I started with 2 points away. We'll come back to that. Let's use 1 point away. Let's not get ahead of ourselves. Let's go with 1 point away. 1 squared is 1 times -3. Let's start with just moving -3 places away. So from our vertex, we're going to go 1 place away and go down 3. Because it said -3, we're going to go down. And then go back and go the other direction from the vertex. So in the negative directions, we want to go 1 place away, and again, down 3. So if you want to check that with the table of values, you're seeing that we did plot the points just now, -2, 5, and 0, 5. That's where those 2 points fell. If you're using this method, that's a good way to check if you're not sure you're doing it correctly. Just type it in the calculator and see where those should fall until you start feeling confident with this work. So now let's try 2 points away. Like we already said, 2 squared is 4, and 4 times -3 is -12. Always remember you're counting from the vertex. So method B is moving from the vertex. So moving from the vertex, we're going to go 2 places away in the x direction and 12 in the negative direction for y. So again, going back to our vertex, go in the negative x direction 2 places from the x, go 2 places, and 12 for the y, but of course going down in the negative direction. And so once again, we can see that did fall at 1, -4, so 1, -4, and -3, -4. So pick the best method that you prefer. If you want to use the graphing calculator and generate a table and just plot those 5 points, or if you want to use the method of counting how many x values and y values away from vertex. So connect those points with a smooth curved line. And of course, we'll finish off by naming the domain and range. Because this is quadratic, the domain is all real numbers. That will always be true for quadratic functions. The graph is opening down, so for the range, our y values are going to be less than or equal to whatever that maximum value was. So if you need to go back to your vertex and look at the y value, or you can just count it on the graph, our range is going to be less than or equal to 8. This graph, every single y value of this function is going to be less than or equal to 8. You can even see that in your table that you generated from the calculator. You will never reach values above that, so that's why we say our range is less than or equal to 8.